Uh, Thank you, Jim. And I want to start off by thanking Tesco for this opportunity to speak with you here today on a topic that's near and dear to me and has been for many years. It's awesome to be in this kind of a venue, the home of the reigning Super Bowl champs. It doesn't get any better than this. I think anyone who has worked around mission-critical communications in any way, both from industry or inside in the public safety agencies, is aware of the historic legislation that was passed last February 2012, establishing the First Responders Network Authority, which is an independent authority under the Department of Commerce. They have an enormous challenge, which is to build a first ever kind of a landmark network that would be used by federal, state, local for broadband wireless needs. First ever of its kind, hoping to finally solve some of the interoperability challenges that have been plaguing public safety for many years, but really at a level of data and video, which is a whole nother plane that I think will be tremendous and will. So they've got an enormous task ahead. I think they're doing a tremendous job with reaching out both to public safety communities through several forums that have occurred so far. In addition, several RFIs that have gone out to industry to kind of present and provide information to industry on what they're looking for and get input on innovation from industry. So with that, I just would like to say that because if you do build, operate, and support broadband, LTE, or long-term evolution networks, there's plenty of information directly from FirstNet. The focus of this session is really then from a different perspective, and really it's from the perspective of the agencies, and that's what I'm most familiar with, from agencies that are looking to ultimately transition over the next decade fully to FirstNet, and to go through many changes in the way that they use and operate their mission-critical communications. So just to talk quickly about the content of this session, first I'm going to go through a kind of a historic view through the evolution of mission-critical communications. I think it's important to kind of take us to where we are today, and then kind of set us up for what the next decade might hold in terms of transitional challenges and opportunities. So I'll go through my background for context, but then also kind of relay it to that evolution. I do have a video with me that kind of visually shows you some of the need from within the Department of Homeland Security. I have to say two things there. One, Department of Homeland Security has an enormous challenge in that most people don't realize, but they have 120 uniformed frontline mission folks that are in some way involved in some mission related to the safety of the United States. So an enormous enforcement agency. I think it's the biggest in the country in terms of an agency that has internal public safety mission. So in addition to that, they have a struggle of 21 private networks that are all kind of creating challenges for the various levels of obsolescence, and they all need attention and work. So the other point I need to make real clear, I'm going to show a video. In that video, you'll see me back when I was the executive director. However, I need to make clear that I'm retired now, so I do not speak for the program anymore, and I do not speak for Department of Homeland Security anymore. I'm just giving you sharing my perspective from my experience. And I just want to make sure nobody left with any confusion over seeing me in the video and thinking I'm still speaking for the agency. And then lastly, I'd like to have some question and answer. I realize there's a lot of other perspective in the room, and I bet several have lived through that same evolution in mission-critical communication that kind of leads us to today. And I'd love to hear, and I think everyone would gain by hearing some of those comments and perspectives in the Q&A. Okay, starting with my background, I consider myself fortunate to have really, I think I've had 3 separate careers in civil service. The first 20 years I spent in federal law enforcement and in investigations. And during that period, I had responsibility for mission-critical networks, so large networks that would be serving the law enforcement end of within the organization. And then also border security technologies, surveillance technologies, radiation detection, RFID, all the different technologies used today along the borders. So had responsibility for them, but did it from within the law enforcement organization. It wasn't until the mid-2000s that the next phase of my career kicked in, which was the CIO IT phase. It was when basically DHS was just formed. It was a brand new organization, and there was a need for several leaders to kind of step up and integrate some of the parts and pieces that were coming in. 22 different agencies came in, and if you could imagine all the different technologies, all the different cultures and staffs that all had to be kind of put together into something that made sense. So my first senior executive position was to manage and put together a large technology support organization of a little more than 3,000. And this group basically supported all of the data center operations within Customs and Border Protection at the borders. It supported the IP networks, the IT network operations centers, the monitoring and the care and feeding of the networks. And it also had the help desk operations so it gave me a different perspective. I only saw it from mission critical in my first 20 years, and now, believe it or not, from the CIO perspective, it's a whole different stovepipe. It's a different culture. It's different, and it's coming, because everything's coming together now, it really helped me to be able to kind of look to the future and look to some of the next generation integration that has to occur between the IT networks and the land mobile radio or mission critical networks. The third phase and final phase of my career was at Department of Homeland Security. They called acquisition program management, and they had a term for level 1 programs. Level 1 programs were programs that were $1 billion plus, and my introduction into that world was baptism by fire. There was a Secure Border Initiative technology program, SBINet, which had been a year in and was into some issues and problems. They were getting a lot of criticism from outside the agency. And at SBINet, you age 2 days for every day you worked there, so it was certainly a challenging situation. The other level 1 program, which was over $1 billion, was I came from that and I moved to the Joint Wireless Program, and it started with CBP. CBP has a 45,000 frontline users in the Border Patrol and at the ports of entry. Those folks had networks that were in various stages of obsolescence. There was a major project that I launched to be able to modernize the networks and build new radio towers to give them coverage in areas that the mission now dictated they needed coverage in. Build a backhaul and do this in a lot of rural, challenging areas. The price tag was over $1 billion, so it kind of got me some attention up top at DHS. And when it got me up there, it kind of morphed this into a DHS-wide joint program office. So it then began, we had an office in Chantilly, Virginia, where we had representatives embedded from Customs and Border Protection, from ICE, from Secret Service, from TSA, from Coast Guard, from FEMA, and from the Federal Protective Service. In addition, right after that was kicked off, the Department of Justice came to us, and we gave 12 seats to the Department of Justice to be embedded in the office. So it was kind of the beginnings of Department of Justice and Department of Homeland Security looking together at the future and working together off common acquisition vehicles, which was what that program office was all about. Okay, so now I'm just going to step through some of the evolution that at least I witnessed and worked through in my time. And I'll start back in the, sadly to say, in the late 70s, early 80s. At that time, as a matter of fact, many that I talked to today refer to that as the good old days because life was simple, right? You had FM analog two-way radio in most cases in most public safety agencies. Most of the world, federal, state, local, was in VHF. There was, I think one study said there was about 80% in VHF, and then UHF was emerging with a small percentage. So, you know, everybody was kind of in the same band. It was all clear audio, FM radio. Most in terms of training, the operators loved it because 2 or 3 channels, you know, they really didn't need to know a lot to use this, which is good, because if you think if you're in pursuit situations, if you're in and you're an operator in the front lines, you don't want to have anything that's very complicated to operate, because you just need some quick, simple way to communicate. The next phase, and this kind of really, the drug war, if you remember in the mid-'80s, was really kind of heating up, and it opened up some new problems. At U.S. Customs and several of the federal investigative agencies, there was a lot of missions now in the drug war in the Caribbean, and we had air and marine groups that were growing in size. We had a lot of coordination for mission-critical communications, and we experienced a wave of shootings that was occurring through these investigations, mainly through ambushes. So agents would be ambushed, and then we'd have several shootings. There was a wave that was kind of disturbing and going on for one after the other. In each of the investigations, what we found was compromised communications was the reason for the ambush, and that was how it was done. So they were getting, buying equipment in the drug war. They had a lot of resources and money, and they were using that to really compromise the mission-critical communications, know what was going on, and then be able to attack our agents. This put a lot of pressure from on top to button things up. So right around that time, industry was just coming out with the first beginnings of voice privacy. It was analog voice privacy. There were a lot of proprietary pieces to it, but we found that we couldn't live without it, at least in some of the large federal agencies. So we scraped together whatever funds that could be scraped together quickly, and we began what I would call my first ever, at least that I experienced, major national transition. Prior to that, networks were built locally by small little local offices. They would almost build them ad hoc at the end of the fiscal year. If there was year-end funds, they would take the year-end funds and add a water tower or add a commercial tower and grow networks. This was the first time we had to go out nationwide and do a total refresh and bring everything up into the secure encrypted voice privacy. So that was done. It was a major challenge. It was done in a record time, at least at U.S. Customs where I was. And when we did that, we found ourselves in a new problem. We now had encrypted radios, but that technology, that early technology, required that you actually go out and touch every radio to be able to change the encryption key. So that meant we had to go into every trunk, we had to get hold of every portable radio, and we had to go to every mountaintop to be able to change the key. We tried it in a test bed, and it took us almost 3 months to do a single key change. And the problem we had was the National Security Agency was requiring that once we had encryption, we had to do a monthly key change. So we had a problem. It was impossible to change the key monthly and the effort took every mission person off the mission lines to get involved in changing keys, which was not desirable. So what we did, and this is the first time I would say we really relied on industry for innovation. And there were some pilot technologies for over-the-air rekeying that were just beginning, but they were very rough. They didn't meet all the requirements, and they really needed to be fine-tuned. So DOD had some funding that they were using for the drug war. Now DOD was getting into the drug war from that perspective to help fund some R&D. And we got some funds, and we worked with some LMR vendors to spend about 1.5 years refining over-the-air rekeying and getting it to work well and work in our environment. So that was our next evolution. Late 80s was to implement over-the-air rekeying and to begin to now set forth the networks. Now the only thing that introduced, you know, everything feeds into the next problem. The thing that introduced was many of these ad hoc local networks had a lot of RF connections. They didn't have wireline connections. In order to have over-the-air rekeying, the architecture had to be changed to have point-to-point circuits connect into hubs and be able from those hubs then to send the keys out through the network. Very expensive. If you think about adding wire lines to at U.S. Customs at the time, we had over 600 remote repeater sites throughout the country. All of them had to be wireline back to hubs. So it gave birth to what we call the National Law Enforcement Communications Center, which was a huge national hub. We folded many of the regional communication capabilities into this national hub. And from there, we had wire lines for the first time connecting to every site in the network. We had teams of dispatchers that would monitor the network 24/7. And then we created this new group of folks called key management specialists. And they really were just database managers. What they would do is create profiles for every user in every part of the organization that determined what keys they would need in what parts of the country. And then that would be the database that would reload and update the keys. That had to be updated on a regular basis. The other thing this began when we did build this capability, the National Law Enforcement Communications Center, with that kind of an architecture, is other agencies didn't want to replicate that. And it didn't make sense for other agencies to spend all that money to replicate that kind of a core. So we began servicing 40 other agencies for the first time. And there wasn't a whole lot of that done back this was early 90s. It was kind of the beginnings of enterprise support and enterprise services, agency to agency, and OTAR really kind of pushed that. Even today, that's still going on, even though the systems are now P25 digital OTAR, we still see that same kind of support for multiple agencies out of a single agency. Okay, so the next big change really occurred mid-90s, and that was the APCO P25 standard. At that time, as many might remember, there was a big push for efficiency. Spectrum was very tight. Everybody was looking for ways to expand that rare resource. And so APCO came out with a way to go narrowband, which was an FCC mandate, but a way to go there using digital standards and protocols. And the reason that was important, as many might know, is if different proprietary vocoders were used to put the voice into a data signal, they couldn't then be able to, they wouldn't be able to talk together at all. So it wasn't like clear audio analog where you can just talk on the same frequency. You now had to have the same standards to be able to have a common air interface, and that's what P25 brought. OMB at this time, though, saw this as a huge opportunity. This, for the first time, they realized that because of the mandate that every federal agency had, that over a 10-year period, they had to update their systems to P25, they now had an opportunity to force sharing at a higher level in organizations. So what they put out, OMB at that time put out a mandate to say, we will not give you any transition money. Any agency that wants to transition their networks, we won't give you money unless we see a plan that shows a departmental level shared system that we don't want each agency to replicate a separate system like we have today. So that created a lot of angst because agencies really didn't want to share and kind of collapse their private networks and be on departmental large networks. We fumbled around for a few years trying to make believe we were going to consolidate and not really do it. And OMB saw right through it, and we got $0 for P25 transition for, I think, 3 or 4 years. And what that led to was ultimately the Department of Justice and the Department of Treasury at the time, ultimately Department of Homeland Security, kind of all joined forces and said, we're not only going to give a departmental shared system, we're going to create a shared system that's across all the law enforcement, most of law enforcement in the federal government, on what they called IWIN, or Integrated Wireless Network. One interesting thing that occurred, this was the first time every agency, everything from the FBI to ATF to Customs to Secret Service, all kind of were part of the same project, and it was the first time that they documented the mission need. It had never been officially documented before, and it was the first time that they actually set up requirements for all these agencies to see what was common, what was unique, what was different. The reason it had never been done before, when I look back, now that I know what I know about acquisition program management, IWIN was a program because it was so large that brought the numbers beyond the billion threshold. And once you go beyond the billion, you now have to put PMP-like acquisition program management in place. So you better have an operational requirements document. You better have a mission need document that guides the whole process. So anyway, when we did that, one interesting point that I'll pass along was that the high-level operational requirement showed that, and most would probably guess this, that every single component had mission-critical voice as their priority one need. And the funny part that nobody realized was right below that, right as a close second, was data and video. And you might ask, why is in the federal government, Department of Justice, Department of Homeland Security, why do they still not have data and video mission critical grade in the mission space? And it's because the plan was first build the, at the time there was going to be a P25 trunk network that supported all these departments. First build that and then put a second network on to bolt it on that would be for broadband data and video. And they never got to the second network because they never finished the voice network. The funding to be able to not only build out these private LMR large networks is so vast across the country with all the coverage requirements that by the time you get close to getting it done, you find yourself in another cycle of refresh, and so you never can move from voice to the second priority, which today has grown. The need for data and video has grown in these agencies, and yet it still goes unmet in terms of mission critical. Now, I don't want to confuse you. There are people that subscribe to commercial service, but those agencies don't consider that mission critical broadband data. They can't use it in most of the mission spaces where they have coverage that's in remote areas that don't have commercial coverage. And in addition, it doesn't have the security and the hardened mission critical needs that the agencies have. So they basically are postponing a lot of that. Okay, so the next phase I just want to talk about was the phase when I really started, as I talked about, getting into the IP. I was charged with building what the Department of Homeland Security called OneNet, which was the enterprise network that all components had to migrate from their legacy IT network onto. So it's kind of like the gig in DoD, which is one network that supports a wide area IT for all. That experience gave me a whole different perspective on my mission critical communications, because it's a whole different way of building networks. There are all kinds of different security requirements related to IT than there are in the mission critical space. But I'll talk about later how it kind of prompted, some of these things. At least in my mind, I started to shape a vision that would kind of pull some of this stuff together. As a matter of fact, one of the things I did in this role was to get some of the engineers from mission critical land mobile radio, P25, and my IP networking engineers, brought them together in a room and kind of charged them with developing what we call the radio over IP strategy. And I think many agencies today are looking at setting up that as a baseline, which we'll talk about for this upcoming evolution, to kind of use radio over IP or IP cores as a launch pad into this next generation of mixing disparate networks. The 9/11 Commission was very strong at that time. This was early 2000s, mid-2000s, pushing for interoperability. And there were lots of challenges that agencies faced with interoperability because the networks were really designed to be little separate pods with walls around them. They weren't designed to actually, openly connect with each other. So you had to go through a lot of convolutions to be able to get interoperability, and it's still something that today, for the most part, is very difficult to obtain. When I moved to SBInet, I'll say real quick, I'm going to move through this quicker, but when I moved to SBInet, one of the things I found, and others might have experienced this in this room, my prime would show me devices that the mission requirements called for. So an LMR radio, maybe a satellite-based voice radio, satellite-based data, data for basically mobile, at the time, WiMAX private networks for broadband data. So each of these networks, while they were being put in a local area, when we projected that out, and I did the math on, every device had a different national network or space-based network. So when you project that out at a cost for just one agency, it was astronomical. There was no way the agency, would be feasible. So we kind of put a hold on that and started to work on a vision for kind of looking more to the commercial model. Where in the commercial model, what you find is a convergence of voice, data, video, all on common, capable LTE type networks. That was the model that we kind of said, hey, let's hold off on meeting our needs that way because it's just not feasible. And let's look to some of these new innovations to be able to converge things as we go forward. And we're not exactly there yet. As you know, voice is not converged. When I say voice, I mean LMR type, P25 type voice, which is one-to-many. That's not there yet, and may be several years before we actually have the innovations that make that possible at a something that we're comfortable with. But that goal of putting most things on a common network and ultimately down the road voice is really where we're at. Okay, so key challenges ahead. Let me get that one. Okay, so let me just talk to, I think most agencies that I met with, especially through that joint wireless office, had a strategy to say, hey, we're going to need P25 for several years to come. So let's build a baseline. Let's maybe not put a ton of money into it by building out coverage and all kinds of capacity, but let's get a baseline and make sure our P25 is updated, modernized, and able to carry us at least 10 to 12 years into the future. We know for sure it's going to be the primary for voice mission-critical communications, but what may occur down the road, and what was hoped to occur down the road, is if there are applications of mission-critical voice, one-to-many voice on LTE, well then we'll still need P25 networks as fail-safes. Everybody would feel you'd have to have them run in parallel for some period of time, so you had life and safety issues addressed and some of the mission-critical needs addressed in parallel. So everybody's working towards that. The other thing that we saw that was pretty evident was that people have gone through and have a lot of scars from the current transitions. What folks really got to understand, especially on the industry side, backward compatibility is a major issue for every agency that looks to a big transition. And the reason I say that is you have multiple ecosystems, you have folks that are moving, teams come in from other areas into a new area. They need to be able to have backward compatibility with the network that's in that area and with the users that are operating in that area. Huge challenge. It's what really makes these things more complex when you go through transitions. So it's something we need to highlight and look to in the next generation. And I think, I've talked to folks that are technical people working in these agencies and also the industry partners that support the technicians, engineers that work in these agencies. And some of them worry that, oh, we're going to go to LTE, so we're not going to need the private network electronics where people have that expertise. I think it's just the opposite. I think this next decade is going to increase the need, because when you add complexity, when you have multiple in parallel systems working, you add confusion and complication to the frontline mission operator. And when you do that, it requires people, technical people inside that help them navigate through these multiple ecosystems. And so I think there'll be not less jobs in this next decade around private and mission-critical communications, but I think there'll be many more jobs needed as more capabilities come in and as more complication enters into the space. I think at this point, there'll be agencies will be looking closely to industry. There'll be a lot of RFIs that come out looking for innovation. And I think companies that are thinking ahead and thinking about what's going to be the next need are really going to be in a position. You can't think about it when the RFI comes out. You really have to plan and have your own internal vision and strategy for what innovations do you want to focus on and anticipate the next need. I think the ultimate goal for everyone is to converge things, but again, as I said, that's going to take years. And during that period, I think people are going to need innovation and assistance from industry. One other thing, there's companies that do PMO support. Huge issue with agencies that are going to require the need to plan their roadmap. Everybody's got a slightly different mix. You know, in agencies at DHS, we had HFALE networks, we had land mobile radio P25, we had analog networks that hadn't been converted yet. Throughout that maze of networks, air-to-ground systems, UAV systems with communications, throughout that maze of networks, we need a customized, or they need a customized transition plan, and companies and industry have to help them with these roadmaps and with tools that help them navigate through that. Okay, so I'm going to stop here and just show a quick video. This is more high level. It's just to kind of give a visual of some of where broadband is needed and kind of give some of the mission folks talking about some of that. So we'll just stop and show that for a minute.
Shots fired, shots fired. Hey, we're taking gunfire at the 14 watch. We need medical support. 10-4, you need additional backup.
10-4.
10-4, we're sending medical support.
Communications are critical for law enforcement and public safety. The September 11, 2001 terrorist attacks on the World Trade Center tragically showed us just how critical. A failure of radios to operate properly and the inability of different public safety groups to communicate with one another by radio contributed to increased fatalities. Efficient and effective radio communications contribute to public safety and life-saving efforts. Agents and officers of the Department of Homeland Security face rugged conditions where communications networks have to withstand hazardous situations. Moving forward, there is a need to transmit mission-critical voice, but also video and biometric data transmissions from the field.
These needs are going unmet today. The need for voice, video, and data is more important today than it's ever been, and yet with all that's being spent, we're not delivering the data and video piece.
Right now, DHS and its components operate more than 20 separate radio networks, serving more than 120,000 frontline agents and officers. Most of these systems were deployed more than 20 years ago and are well beyond their intended service life. They don't provide sufficient coverage in remote locations, and many do not meet federal mandates for encryption security and spectrum efficiency.
At the Department of Homeland Security, we're spending billions of dollars to deliver another generation of voice-only communication. These systems do not meet the mission-critical needs. They deliver strictly voice, and they're not meeting the need for data and video or interoperability, which is long desired by the 9/11 Commission.
Limiting communications to voice-only transmission means in some cases agencies are not able to fully take advantage of resources that would lead to better situational awareness and enhanced officer and public safety.
For example, we have high-resolution pictures from UAVs, from fixed tower videos, and the responding unit can only get a description of that verbally in a voice-only system. In addition, we can't see back in the infrastructure what the operator sees. There's no ability to send back pictures and video into the ops center. So not only from a mission effectiveness, but from an officer safety perspective, that capability would be greatly enhanced with mobile broadband and the ability to bring voice, video, and data into the mission space.
Ensuring all these systems will work together requires a new vision.
The traditional business model that we use for mission-critical voice systems today relies upon building, owning, and operating private networks that serve a very small user population.
According to DHS estimates, if it were to remain on the private radio cycle, $3.2 billion is needed just to upgrade existing systems department-wide. U.S. Customs and Border Protection alone has been upgrading its radio systems with an annual investment of $40 million. Continuing at its current pace, CBP projects its radio modernization would take more than 20 years to complete at a cost of approximately $1.3 billion, not including maintenance expenses.
What DHS senior leadership is looking for is a game-changing approach, something that allows us to invest in a capability that will give us not only our mission critical voice needs, but also our data and video needs, and something that allow us to begin to do that relatively soon. We're looking to industry to help us using today's commercial mobility standards for long-term evolution, or LTE, which provide a whole ecosystem of lower cost devices and applications that would allow broadband into the mission space.
The Joint Wireless Program Management Office was chartered by DHS to promote a government-wide approach to wireless communications modernization. It's a three-pronged effort. First, the office serves as a central collaboration point for DHS components and partner organizations to promote standards for land mobile radio upgrades. Cost benefits can be facilitated through bulk purchasing. Second, the Joint Wireless Program promotes digital communications platforms and a tactical interoperability framework. Finally, the Joint Wireless effort stimulates technology development while creating partnerships and working with commercial entities on the Tactical Communications Network program. The DHS Joint Wireless Office is now partnering with the Department of Justice on wireless programs. It is also fully committed to the First Responders Network Authority. FirstNet, an independent authority established by the Department of Commerce, is building the nationwide public safety broadband network for federal, state, and local first responders. The goal of the joint wireless effort is to migrate to FirstNet and working with industry to develop next-generation capabilities to ease that migration and potentially use secure commercial services on a subscription basis when needed. The Joint Wireless TACnet program promotes the building of innovative technologies through its Technology Demonstrator Project to converge narrowband voice communications with broadband data and video. Commercial long-term evolution technology fills in the gaps. That's the graceful migration path as the FirstNet nationwide public safety broadband network is built over the next several years. It's the smart approach to smart technology.
Roger. And yep. All right. And survivors coming in. Survivors coming in.
Okay, so I'm going to blow through the last two slides, which kind of talk about what this next decade, I think, will offer in terms of opportunities. But I just want to define one thing and do this real quick. Talk around. This has been a big challenge for public safety. A lot of the devices that commercial vendors provide today are low-power devices that require a network connection to be able to have a talk group. This is what we saw with Nextel years ago. We've seen these kinds of commercial, and the power levels that are mandated on commercial networks are much lower than what we see on land mobile radio private networks. The problem we have is that there will be a continued need in public safety for direct communications, robust direct communications, which will give a 5 to 7 mile range. If you have somebody in a sub-basement, somebody up on a roof, that group doesn't have to worry about somebody dropping out of a network coverage to be able to communicate. So I believe, just my own personal opinion, I think hybrid radios that mix LMR and have access to broadband talk groups on LTE networks, I think ultimately those will be the beginning devices that make sure that public safety gets its talk around, robust LMR talk around, which has been optimized for decades on LMR radios, with batteries that can give a full shift, 8 to 12 hours of battery life, 5 watts, 4 watts of power, and give you that kind of robust capability. So it's my own prediction, but I think a hybrid is the initial answer to be able to begin to introduce voice. The other thing, I think these IP cores and an IP radio over IP kind of background, that's critical for interoperability, and it's also critical for a launch pad. I think even internationally, agencies I worked with, RCMP, others that we talked to and worked with, are all thinking about radio over IP as a launch pad for the future and to connect disparate networks in an efficient way without having to try to communicate directly on every band. Opportunities real quick. I think those who build and support and operate LTE networks, there'll be plenty of opportunity, which are obvious. I think those who build LMR, ALE, HFALE, SATCOM, other types of private mission-critical space radios, there'll be plenty of opportunities in the next decade that will be growing in those spaces. I think opportunity for radio over IP, so mixing the CIO, IT world and networks with the mission-critical worlds, lots of new opportunity there, lots of look to industry for products that will begin to integrate a lot more and manage some of what happens on the IP side. Program management, as I mentioned, the ability to help people with transitions, transitional planning, roadmaps, be able to customize that for different agencies. New accessories that help people deal with the migration pains. So new tools, accessories, equipment, innovation from industry is going to be looked to there to make seamless migrations. These networks, these systems have to migrate seamlessly, and they have to navigate through multiple networks. Those who build apps, mission-critical data apps and video apps. Think about if every user in the network now has video that can go back into the network, what the infrastructure is not prepared to manage that. They can't even store, it's unstructured data. How does it even get stored, analyzed, processed? It's not any good unless you can, so there's going to be looks to industry for apps that can help manage and utilize the data and also the video. And those who manage and deliver security, wireless security and management for a lot of the commercial devices. The government, as they move into commercial devices, are going to need a higher level of security on those devices, and they're going to need a higher level of or an ability to manage them as a fleet. So I think industry is going to, and already is, coming through with a lot of solutions on commercial devices geared to that customer. Okay? Again, thank Tesco for this opportunity, and thank all of you for coming out to listen here today. I appreciate it.